Welcome back to my YouTube channel. I am Xavier Smith, and today I am going to teach you how to graph tangent that has a b value. So that means its period is different than just pi. So let's start at the standard form of tangent. We have y equals a tangent b of x minus h plus k. Today, we are isolating this b value here. What does b do? Well, it determines period. That's really specific, right? Our period is pi over b, because remember, tangent has a period of pi. And if we said, well, what if b is 2? Then you would have pi over 2 would be your period. If b is 1/2, then you'd have 2 pi be your period. Because if you think about this, if we had b is 2, tangent 2 of x. If we plugged in x as, let's say, 1/2, we plug in pi over 2. Then that pi over 2 is really pi, and we don't graph pi. So if we plugged in pi over 4 into this, it would be 2 times pi over 4 would be pi over 2. So the point at pi over 4 should really be the point that was at pi over 2, which would be an asymptote. You'll see what I'm talking about. Let's just get started. Okay, period. We have y equals tangent x from negative pi over 2 to pi over 2. Then our points go negative pi over 2, our halfway point's negative pi over 4. Then 0 is our middle point. Then we have pi over 4, then pi over 2. So let's first plug in a b of 1/2. If we plug in a b of 1/2, we'll have y equals tangent 1/2 of x. Plug that into pi over b, which is pi over 1/2, equals 2b. 2 pi, sorry. So our period is now 2 pi. And if you look at what I was just saying earlier, we have our 0, 0, right? Base point doesn't change. You plug in 0, 1/2 of 0 is still 0. So you get 0, 0, still the same point. But then 1/2 is at 1, which usually pi over 4 is at 1. So if we plug in pi over 2 to this equation, 1/2, tangent 1/2 of pi over 2. 1/2 of pi over 2 is pi over 4. So at pi over 2, we're really taking the tangent of pi over 4, and the tangent of pi over 4 is 1. Might make sense, might not. But at pi over 2, it's 1. Now at pi is the vertical asymptote. So at pi, if we plugged in pi to this equation, tangent 1/2 of pi is tangent pi over 2. Well, what's normally tangent pi over 2? Tangent pi over 2 is normally a vertical asymptote. So in this equation, at pi, we have a vertical asymptote. And it goes the same for negative pi over 2 and negative pi. So our graph, when b is 1/2 and our period is then 2 pi, our graph is stretched out by a factor of 2. Then if we plug in b equals 2, y equals tangent 2x, which would mean our period is pi over b is pi over 2. So our graph is compressed by a factor of 2. So when b is greater than 1, our graph is compressed. When b is less than 1, our graph is expanded, stretched out. So we have 0, 0 again. You plug in 0, you're going to get tangent 2 of 0, 2 times 0. 2 times 0 is still 0. So you're always going to get the 0, 0 point. Then we see, oh, well, pi over 8 is at the point where pi over 4 should be, because pi over 8, 1. Well, let's plug it in. Tangent 2 of pi over 8 is really tangent of pi over 4. So here, at pi over 8, you are getting the y value, the output that should be given for pi over 4. And then at pi over 4, if we plug that in, y equals tangent 2 times pi over 4. 2 times pi over 4 is pi over 2. So if we have y equals tangent pi over 2, well, that is a vertical asymptote. So at pi over 4 in this equation, we really have the output of pi over 2. So vertical asymptote, and then here at pi over 8, it is 1, 0, 0. It's always there. Then it's the same for negative pi over 8 and negative pi over 4. You plug those in. You're plugging in negative pi over 4. You're going to get negative pi over 2, vertical asymptote. So once you plug in your input in this equation, if we plugged in pi over 4, our input, it would be pi over 4 times 2 is pi over 2. Then it's like taking the tangent. You just take the tangent of pi over 2. What is the tangent of pi over 2? Undefined. So we put in the input of this scale, this graph, into this equation, and we're going to get the output of another variable. So you put in pi over 4, but you're really getting the output of pi over 2. Thank you for watching. I hope this was helpful, and I will see you next time.